people know.
Hello, guys. Welcome. I'm going to keep waiting a little bit to give people time to jump in. Wait 2 or 3 more minutes. All right, we'll just wait 1 more minute, guys, and we'll get started. See if anyone else jumps in. All right, it is 5 after, so let's get started. Welcome to the power of RAG, aka Retrieval Augmented Generation. My name is Alec High, and with me I have Jose Cadena. We are part of the team at Salient Process, a gold IBM business partner specializing in process improvement. And today we are hoping to give you a 101 crash course on retrieval augmented generation, and as it relates to generative AI, a topic we know that is a high priority in almost every business today. Specifically, we're going to look at what is RAG, how you can get the most out of it, and how it relates to process improvement. And we will also get a technical breakdown and a live demo by Jose. So let's get started with just the basic, what is RAG? Essentially, what RAG is going to do is going to improve an LLM by grounding it in specialized and up-to-date information. This means that it will incorporate data specific to your business, whether that is being stored in a PDF, if it's on a website, or if it's in a database like your CRM or an ERP. Now, you might say, LLMs are already trained on massive amounts of data. Why do I need to provide it with more data? And ChatGPT is already doing a great job of helping me write emails and doing basic research. So let's take a look at a couple examples of what can happen if you use an ungrounded LLM in the business context. So our first story is a New York law firm that looked to ChatGPT to help create a legal brief. ChatGPT, of course, had no context on this particular lawsuit, but it still tried its best and created 6 completely fake cases that the law firm then used in their legal briefing. Once this was found out, they got hit with a $5,000 fine, and probably bigger than that fine is the hit to the reputation that they took, making them look a little bit sloppy. But let's be clear that this is not a bad Gen AI use case. Creating a legal brief is a great use for that, but we just need to make sure that we're using relevant information. Another instance of this was Air Canada. The airline created a chatbot to help their clients more easily reschedule and collect refunds from canceled flights. And a passenger was trying to do exactly that after his flight got canceled from a snowstorm. And the chatbot ended up giving him an incorrect response on what the refund policy was. This again led to a lawsuit, and Air Canada had to honor what the chatbot produced as far as the refund policy, which was incorrect. Again, a great Gen AI use case, just not done with the proper data in place, showing that the chatbot was not ready for production, which led to failure to take care of a customer and another hit to reputation. So what is happening here, and why are we getting all these fake responses from the large language models? Well, you may have heard the term hallucination as it relates to AI, and this is because large language models are fully reliant on their pre-trained data, and they predict a pattern to then generate an output. This data that they are given, however, is completely static, meaning it does not get updated automatically. Additionally, they will generate an output regardless if the pattern they are just detecting exists or not. And when they do this, producing in non-existing response, we call it a hallucination. And it can be very tough to detect because the LLM appears very confident. And this poses a very big risk to businesses looking to utilize these large language models in the instance of the law firm or Air Canada. Now, we can't eliminate hallucinations altogether, but with RAG, we can help overcome and mitigate these errors by providing it data that is up to date and that is specific to your business. If you do this, you can be sure you're going to get much more accurate responses that are up to date. And if you're just getting started in your AI practice, you can be sure that you're starting off on the right foot in the way that you are scaling it throughout the different departments, and that you're going to get good decision making based off of the users using that LLM. So now that we've looked at the what and the why, let's pass things over to Jose, and he will break down how this all works.
Yep, sounds good. Thank you, Alec. So before we jump into the demo, let's set some ground on the basics and see why do we need this type of implementations like retrieval augmented generation to make the most out of the foundation models that we're going to use. So as we know, There are two different types of models or the language models. The first one being, I like if you can pass the, yep.
Okay.
First one being the,
Mi casa es lo máximo.
sorry. So yeah, as we know, there are two types of models. The first one being traditional AI models. The main difference between these and foundation models is that traditional models are built from scratch. Given that they are built from scratch, we kind of are aware of the data that we're using, leading this to be that traditional models are only good for one specific only, or for one only task, for one task only. Although these type of models are going to be pretty accurate and pretty good on that specific task that we train the model for. If we want to expand the range of usability of these type of models, then we will require some additional training or even build a new model from scratch, limiting the functionality or the flexibility to use those. One clear example of this, it's the type of models that use Alexa or Siri that we might use on a daily basis, which main task is to do the speech recognition. Now, the other type of models that are available, it's the foundation models, which is the main focus today. Uh, I'll if you can pass the. So foundation models, again, the main difference is that these are pre-built models that are available to users so they can access to them, use them for different type of tasks like text generation, uh, data extraction, speech recognition. Uh, Now, since these type of models are trained with a massive amount of data, uh, we're gonna start seeing some issues or some limitations within it. The first thing being the cost or the high resource consuming that these models may be. So if we want to train a model from scratch of this type, it's going to be pretty expensive, and we're going to have a lot of resources. So it's probably not worth it to retrain the model or these type of models. Uh, on the other hand, since the training occurred on a previous time, the data that will be available will be limited to a specific daytime. So if we're looking for more accurate or for more current information or maybe concepts that come up after after the model was trained, then we're gonna start seeing some discrepancies on the information provided by the model and so on. Now, again, since it's pretty high cost to train those models, uh, but they're pretty usable because they're pretty flexible on the capabilities that we can do or the different types of tasks that we can do with them. We can implement some sort of techniques to improve those. One of those being Retrieval Augmented Generation, aka RAG. But how does RAG works? Of course, one example of a foundation model could be ChatGPT that probably most of us have used at least once in our lives. And the experience or how we interact with foundation model like ChatGPT, it's going to be a chat user interface where we're going to pass a prompt or a question to the model. And based on the data that the foundation model was pre-trained with, it's going to generate our response, right? So the prompt is going directly to the model, the prompt being the question that we put on the chat. And again, we obtain our response from the foundation model. Now, if we want to implement RAG or Retrieval Augmented Generation, the user experience is going to be basically the same, where we only going to pass the question or the prompt to the foundation model. But before this prompt going directly to the model, we're going to add an additional step, which is kind of like the bots that we've seen in the flow below, which is the search and retrieval. So what is happening is that the prompt, it's going to become a question or it's going to be separated into multiple questions. And what we're going to do is that we're going to use a knowledge base, which is all the different types of documents that we're going to provide the foundation model with. And based on the question, we're going to look for information that it's relevant for that question available in the documents, right? So at the end, what we're going to obtain, it's going to be a list of search results that are going to match, or the concepts are going to match with what we provided on the prompt, right? Now, the combination with the original prompt or the original question plus the search results, in addition to the instructions that we're going to provide the language model with, now, a combination of all of this, it's gonna all happening in the background. So again, we don't need to worry about setting up the instructions. We're only worrying about passing the prompt to the language model. Now, between the question, the instructions, and the search results, this all gonna go to the foundation model. And now, based on the additional information that we provided, it's gonna generate a more accurate or a more updated response from the prompt that we provide, right? Now, to actually build an implementation like this, we're gonna need three main components. The first one being the knowledge base. So again, the knowledge base is gonna be the new source of truth for the foundation model. So it's gonna be the complement documentation that we're gonna fit the model with. This could be different types of documentation like PDF documents. We can also, depending on the application that we're using, we can create integrations with some share folders like SharePoint or maybe bots to retrieve the documents from that specific application. Or we can also do some web scraping, which is basically extracted information from a specific URL. Now that's going to be the first part, the knowledge base, which again, it's going to be the complementary source of truth for the foundation model. The second component that we're going to require, it's going to be the retriever. Now the retriever is going to be in charge of that additional bots that we put on the flow on the previous slide, which is basically based on the question or the prompt that the user sent to the foundation model. It's gonna search through all of that knowledge base or source of truth. What is the most relevant information that matches with what the user is asking about, right? Now, for this, we also have some different applications available within the IBM portfolio, like Watson Discovery, Watson Edge Discovery, or we can also implement other types of technologies like vector databases like Melbus. Now, again, the retriever will be the part in charge of extracting the relevant information from the knowledge base. And the third component that we will require, it's going to be the generator, which is going to be the foundation model that we're going to use. We also have a platform available within the IBM portfolio, which is watsonx.ai and the watsonx platform, in which we can use different foundation models available like Llama, IBM Granite, Mistral, and so on. Or we can also use maybe a traditional model that you have available. You can fit that into the application and use that as the model of reference to this implementation. Now, this will be the how it's gonna be built. Now let's actually see how it will work. So I'm gonna share my screen now. So for the demo today, we're gonna use the watsonx platform that I was mentioning before. As you can see, again, this is gonna be, the user experience is gonna be pretty much the same as ChatGPT, where you're gonna have a chat available. You're gonna start typing the information that you're looking for. As we know, we can do complex things with foundation models like writing emails, doing data extraction, doing some text generation, and so on. But usually for this type of task, we will require some specific information so this task can be completed. Now, this could be from as general as possible, like for example, who is the current US president of the United States? Now, if we send that to the language model, in this case, we're gonna use for the demo the Mr. Large, but as I was mentioning before, you can have the flexibility to use different types of models to compare the results and see the accuracy of each of them. Now, if we ask us a simple question as who is the US president, you will see that the information that the language model is going to provide is going to be out of date because of the time of when that specific language model was trained on. It was probably around 2023. maybe if we do another general question, like who are the current champions of two major sports, again, it's going to provide information that it's out of date. Of course, this might seem pretty standard because it was just a year ago or 2 years ago, so it might not feel like too outdated information. But once time is gonna pass, then we're gonna increase kind of like the range of that information, of that discrepancy of the information provided, right? Now, another scenario could be if we ask for concepts that come up after the trend happened. Like, for example, if we ask what is IBM Granite, as we know, IBM Granite is one of the foundation models that IBM is generating. If we ask to this specific language model what that is, it's gonna try to generate a general response. You might notice that it's actually talking more about the IBM piece than the actual Granite application, creating that part of the hallucination that Gali was mentioning, where it's just going to try to generate our response as general as possible that might fit on what we're looking for. And another scenario that we can use or that we can see some discrepancy or inaccuracy when we're trying to interact with a language model. It's for specific data, maybe some company policies that are in place that might change every year or that are in place a long time ago. In this case, we're just going to use some of our policies that we have. Like, for example, if we ask what are the silent process values, you will see that it's going to try to generate a response that it might applicable to any company worldwide, but it's not going to give us the specific details that we might require to complete that specific task. You can also ask, for example, when the paychecks are processed inside in process, which might be part of the kind of like the policies in place. Again, it's going to try to generate our response as general as possible that might apply to every company, but it's not going to give us the details that we are looking for. Now, so I already asked a couple of questions here. Of course, this was without the rack implementation. So it will be like how we will interact with the language model on a daily basis without the improvement. Now let's see what happens once we apply a rack into this specific model. So what I'm gonna do is I'm gonna clear the chat and I'm gonna ground this model or uh, this specific chat with some documentation in it. As you can see, you can have multiple documents that might apply to different scenarios. In this case, they are, of course, focused on the questions that I just asked the foundation model. Now, let's see what happens if I ask again the whole same question. In this case, we're going to start with the basics, like who's the US president. You'll see that once I provided that additional documentation, I don't need to worry about doing anything like in the background or maybe provided just additional instructions to the foundation model. Everything is happening in the background. All I need to do is supply the foundation model with the documents that I'm going to use for that. Now, if I ask the second question, like the current champions of the two sports, you will see again that the information that now it's providing, it's accurate, it's updated to the latest information that we have available, and it's also providing additional information of, for example, of which documents where that specific information come from. Now we can do the same with the rest of the questions, like what is IBM Granite? You will see that now it's actually giving me the concept that IBM Granite are foundation models available that are created by IBM and giving us some additional details that are available in the documentation. And finally, the questions about the policies of our specific industry. Again, in this case, what we're doing is just asking specific questions to the foundation model. But we can see that once we provide that additional documentation or that additional source of truth to the foundation model, we're actually going to see better results, more accurate, avoiding that hallucination that might generate discrepancies on the more complex tasks that we can start asking the foundation models to complement it. Because if the basic data that that the foundation model is going to provide is inaccurate, everything that goes from there is going to be the same, right? So yeah, that will be again to highlight it's that the comparison between the results of the two scenarios without the documentation and with the documentation. Once we provide that additional source of truth, we can start seeing better results, more improvement, more accuracy. And from there, we can start doing the complex tasks that we need, that we usually do, and that we use with the foundation models.
Awesome. Thank you, Jose, for showing us how the difference looks between using RAG when interacting with the LLM and not having the RAG involved. So now that we've looked at all of that, let's look at where you could start finding areas to implement RAG in your business. Let's start with an example in the financial world. So wouldn't it be nice for financial analysts and accountants if they could use Gen AI to create their financial analyses? They could try this with an LLM, but it would struggle because it does not have current financial standards or information relevant to that business. With RAG, you can give it exactly that, feeding it up-to-date balance sheets, income statements, cash flow reports, accounting standards, anything you would need to create a good report. So rather than manually looking through hundreds of pages and piecing together a report, those analysts and accountants can use the Gen AI to search for those documents and then piece together the report for analysis. In another instance, we could use it to improve healthcare bots. Typically, they are set up with pre-programmed responses. If you tried to open this up with Gen AI specifically, patients would probably get a wide range of incorrect informations. But if we connect it with RAG, we can upload medical guidelines, patient policy documents, and electronic health records specific to that hospital or those patients so that they can address specific needs. This is going to make the patient experience much, much better and take a huge burden off of the staff admin or nurses who were previously handling those responses. Now, there's dozens of use cases like this that you could search through. I'm not going to read through all of these, but in your business, anywhere that you are looking to gain access to information faster and use that to generate some kind of response, a report, a piece of content, or an alert, then RAG is going to be essential for you. So just to wrap things up here, we looked at how LLMs are so completely reliant on their pre-trained data. This is outdated and has nothing to do with your business. And it will end up generating inaccurate responses that could be potentially harmful to your business. RAG is going to help you overcome this by grounding it in specialized data, and that will greatly minimize those contradictions and inconsistencies that you might see in the responses generated. If you have any thoughts or ideas of where you could use this in your business, please reach out to us. If not, thank you for watching. We'll stay on for questions. I know we're getting close to the end, but we'll be here for any questions. If you need to get on to the rest of your day, thank you for joining. So I think in the chat bot, there's a Q&A section. If you have any questions, please drop them there. All right, it doesn't seem like we have any questions at the moment, so we'll go ahead and wrap things up. But thank you all for joining.